In the previous class, we have discussed on signal flow graphs, and signal flow graphs mainly deals with the graphical representation where you have branches and nodes, and this is the representation of signal flow graph. You can see the block diagram here, and this block diagram can be represented in the form of a signal flow graph where you have nodes and branches. So you have seen this circle represents the nodes, and this lines represent the branches. So these things we have discussed in the previous class. So these are the branches, and this circle represents the nodes, and this lines with the arrow mark represent the branches. So this much at least you should know. So that's the reason, if you have not attended the previous class, I thought of just briefing you these things. So we have studied the terminologies of SFG, and where you have seen the nodes, branches, and all what I have discussed with you. And then we moved on with input and output node. So the starting node, whichever at this, where you have all the branches moving outwards towards the other nodes, then you call it as input. And if you have this output node where the branches point towards the node, then you call it as a output node or sync node. The input is called as source node. So these things we have discussed in the yesterday's class. And you have chain node and forward path. So chain node having both incoming and outgoing branches is called as the chain node, and where you have x2, x3, x4, x5, x6, and x7 in this figure. So both the input as well as output no branches should be there. Branches coming in and out has to be there to call it as a chain node. And then you have forward path. Forward path means very simple. If you are coming from one point towards another point, you should not touch any of the places again. So any of the places here indicates that any of the nodes. Okay, once you leave that node, you should not come back to that node again. So if you go without touching the node again, then you will get the forward path from source to the destination. Okay, so here in this case you can see that x1, x2, x3, this one x1, x2, x3, x4, x5, x6, like this straight till x8. It gives you the forward path. So that is what you have to understand. So all these concepts are very important. Some 4 5 students, some of them have not attended last class, so you should understand these things. So then you have forward path and forward path loop, for path loop. Then that is the loop originated and terminated at the same node. So these things like forward path and all these things will be used in the problems as well. So it's very simple to understand. Once you leave one point, for example x1, then you keep going x1, x2, x3. You should not come back to x2 or x3 again. You should keep going front without coming back to the same node. Then it is called as a forward path until it reaches the destination. Okay, so those things is what we discussed in the yesterday's class. And then moving on further, so you have loop. We have seen loop as well. The path which originates and terminates in the same node, and self loop also we have seen. At node 5, you could have seen that self node which is at the same point. You can see here, I can just show you that. This is the self node, that is which is coming from the same node, and it ends in the same node. So that is called as the self loop. Okay, and then self loop, one important thing what we discussed in the previous class is self loop should not be taken in account in determining the forward path and or feedback path. So that is one you have to understand. And moving on further, we will understand on dummy nodes also. We have discussed dummy nodes are the nodes where you can see that if you start this point, this node, it is having both outgoing and incoming branches. So what you have to do is you have to extend one node here. This node acts as the dummy node. So where the gain is 1 and all those things, this complete. Here in the output side also you can have a node here which acts as the dummy node. So this much we have discussed yesterday's class, as well as we have discussed on non-touching loops also. So what do you mean by a loop is like here if I start from this point, you can see this keeps going, and this ends in the same node. So what you can see, this forms one loop. And if you go from this node, if you can see here, you can see that it ends in the same node, it forms another loop. And here if you start from this node, you can see that it ends in the same node, it forms another loop. So you have 1, 2 and 3 loops. So non-touching means, from the name itself it's very clear that the loop should not touch each other. If the loop should not touch each other means the loop should not have common nodes sharing for them. So if in this case the node in the loop 1 and loop 3, these two are not touching each other, so these loops are called as the non-touching loops. This is what we discussed in the previous class to define with in so you have any doubts with respect to that, please feel free to contact me or your friends. Get the things cleared, or you can just go through the yesterday's class I have recorded. You can go through the recorded videos as well and make the things clear for you. Okay, don't just means you should understand these things. These classes are very important for you to understand because we are going to solve the numericals based on whatever we are doing it straight now. So all of you are available now in this group, right? Sai, everyone has come to this?
Yes, sir.
Okay. So we'll continue for from here on. What all things we have to discuss further is the forward path and forward path gain. So just all of you have drawn this diagram, I hope so, the previous diagram. So that diagram is very important for us to discuss this. So forward path and forward path gain. So now we are going to discuss the forward path and forward path gain. So all of you have to just go through this diagram. I think all of you have drawn this diagram. So all of you have drawn that diagram in the previous class.
Yes.
Okay. So we will continue with this. First, you just note down this, what is forward path and forward path gain. Then once you write it, no, you will understand. I will explain it further. So forward path and forward path gain. A forward path is a path from. I have already discussed with you what do you mean by a forward path. Means if you start from one node, it should end up with the last node without repeating the nodes further. So a forward path is a path from input node to output node that does not enter any node more than once and follows the direction of the signal flow. The forward path gain is defined as the product of gains in the forward path, that is called as a forward path gain. So there are two forward path gain. So we will see that this what I am going to discuss now about forward path and forward path gain is very important to understand the problems, and we will be discussing further Mason's gain formula for solving the problems and all. So you should know what do you mean by forward path and forward path gain. So just understand these things carefully, and we will discuss further. So just note down these things. I will explain it once you complete it. I will explain that once more with the figure, so it will be clear for you. Just complete, write down these points. So if you have completed this one, forward path and forward path gain.
Yes, sir.
Okay. So we will just discuss upon that. Now just see this figure. All of you have this figure. So first we'll define the forward path and then we'll define the forward path gain. So can you just say the forward path here? How many forward path is there? As you say, I will keep marking it. So if I start from here, how many forward path is there? So you have to reach to C. This point you should reach from the input and your node should not get repeated. How many forward path is there? Any one of you can just tell?
4, sir.
2, sir.
2 is only there. You should not see in forward path what it is there. You should not repeat the nodes once again. So let us see that this we are going to this way. So everything is clear. We will reach the destination. So this is one path. Correct? So another path which is possible. Can we go in this form? Can we go in this way? It is not possible because the arrow mark is pointing towards this side. So it is not possible for us to go this way. So that path is eliminated. What is the next path?
G1, G5, sir.
G1 and G5.
Yeah, that any other path is possible? So this is the other path. So only two paths are possible in this correct in this figure. Others are all coming means the loops are getting repeated, means the nodes are getting repeated. So it is not possible to select any other forward path. Forward path means once you leave the node, you should not come to that node again. Okay, so so these two are the only possibility of forward path. So how to write? So we'll write it as path 1. Path 1 we'll write it as P1 and the next path is P2. So we have to multiply the gain to get the forward path gain. So this forward path gain, to get that forward path gain, what we have to do is P1 and P2. So what we have written, P1 is equal to G1, G2, G3, G4 and P2 is equal to G1 and G5. See here. This path is G1 and G5, that is path 2, and G1, G2, G3 and G4 is path 1. So you got P1 and P2, all of you? All of you got path 1 and
Yes, sir.
path 2. Is that clear? See, this forward path and its gain is very important. It's clear for everyone.
Yes, sir.
Yes, sir.
So next we'll move on to loop and loop gain. So this is also required for you to understand. Anyhow, loop I have already discussed with you in the same figure how many loops are there, and if you see with gain, you have to multiply it by G and H and all those things. So you can see that, write down loop and loop gain. So the loop gain is the product of all branch gain in the loop. We'll have 3 loops in this figure. Okay, L1, L2 and L3. So let us see that L1, L2 and L3. So whether you are able to track L1, L2 and L3? So you write these things. Then I will go to the figure and just explain it once again for you. Are you able to write these things? L1, L2, and L3?
Yes, sir.
Okay. So let us see that what do you mean by loop and loop gain. We have seen what is meant by forward path and forward path gain. So we'll see loop and loop gain as well. So go back to the figure. All of you have completed writing it.
Yes, sir.
Yes, sir.
Go back to the figure. Yeah, go back to the figure. So we will see that how the loops are there. Can anyone of you say that how the loops are going to be? I have already explained you the loops. So what are the loops here? This one. So this is one loop. So it starts from here. So this is one loop. And next loop is see here. You try to do it. Already we have discussed no these things. You can just try that. So this is the loop 1. This is the loop. So you can see that another loop is which one? Which is the other loop? So you can see that this is the loop.
G3H2.
Yeah. So this is for one loop. This is another loop. Already I have told you this. And this is another loop. Any other loops are there? Is it possible to have a loop like this? It's not possible. So there is no loop there. So these are the three loops possible. So how you can go ahead with that? So let us write for the first one, this one. So what it will be?
Minus G2H1, sir.
G2 into minus H1, so minus G2 H1. So this is first one. Second one is what? This one.
Minus G3H2, sir.
Minus G3 H2, that it is loop, so you have to write L1, L2 and L3. So this one will be
Minus H3, sir.
minus H3. So that is what you can see here. I have written L1 is equal to minus G2H1, L2 is minus G3H2 and L3 is minus H3. Any other loops are possible? Any other loops are possible in that figure?
No, sir.
No. So these are the only possibility of having in that if you take that you have two forward path and three loops possible. Beyond this two forward paths and three loops, nothing else is possible. So this is what you can see here. Then we will see the, if you are clear with it, any doubts?
No, sir.
Yeah, so this is very important. What is forward path and forward path gain and loop gain. So this you should understand carefully. So let us move on further. So here we have studied all the terminologies. Now we will study how to solve the problems in this. So we are going to see the Mason's gain formula to understand what it is actually. So you can just note down these things. I will explain all together. Okay. So this much is Mason's gain formula. Then we will be solving the problems based on the Mason's gain formula and then proceed further. So first let me just give a brief about it. One more time I'll get back to this. Before understanding Mason's gain formula, you should be very clear with what do you mean by forward path, what do you mean by loop, what do you mean by loop gain, or what is forward path gain, and all those things. So everything, if it is clear for you, then it becomes easy for you to understand how these things can be discussed further. So all of you write down Mason's gain formula. So Mason's gain formula is used to find out the transfer function. So what we were doing in block diagram reduction and all those things, we were finding out the transfer function. So Mason's gain formula is also used to find out the transfer function. Transfer function, you know that it is C of S by R of S of the signal flow graph. What is the advantage of this formula is that the system transfer function are readily obtained without manipulating the graph. So Mason's gain formula is given by T of S is equal to C of S by R of S is called as the transfer function. It is given in this form: summation of I is equal to 1 to n Pi delta I divided by delta. We will define everything one after the other. So Mason's gain formula is used to find the transfer function, and this transfer function is defined as C of S by R of S. And here, like in block diagram reduction, no, we are not going to reduce the steps and all those things. From the question itself, we are going to write the some path, its path, forward path, and its loop gain, and all those things, and we are going to solve it further. So here there is no manipulation being carried out with respect to the means whatever question you are being given, you are going to straight away use the Mason's gain formula and going to solve it. So first of all, we have to understand here is Mason's gain formula is used in order to find out the transfer function, and you are going to go ahead with transfer function, and you have equation to find out transfer function, that is C of S by R of S, and the equation is summation of I is equal to 1 to n Pi delta I by delta. We will see what is delta and what is delta I. So P is forward path. So it is Pi stands for like in the previous example you have seen there is two path P1 and P2. That's that about Pi. But delta and delta I we are going to see. We have to understand what really delta and delta I is all about. So you just write down till here, and we will continue further. So all of you complete till here. So you should carefully understand what is delta and what is delta I. So when you solve some numericals, it will be you will be able to understand better than here. So when you solve the first numerical, you will come to know what is the loop, what is the loop gain, and how this has to be written in the formula and how to solve it. So we will still we have to discuss about delta and delta I. We'll see that. So once you complete it, just let me know that this is the equation what you have to understand. Summation of I is equal to 1 to n Pi delta I divided by delta. You have completed?
Yes, sir.
So we will see that the transfer function T of S is equal to C of S by R of S. Summation of I is equal to 1 to n Pi delta I divided by delta. We will just try to understand what is n, what is I, what is delta I and what the value of delta and all those things. So we will try to understand pi, then delta I, and this summation part and this delta. So if you understand these things, we can try to solve this problem. So let us try with that. So you should know that we are going to find the transfer function, and so it is C of S by R of S. So C of S by R of S is called as a transfer function. In the equation, n stands for n is the number forward path, as I have told you in the uh, previous thing. You have previous example what you have seen as the number of forward path. So you can see that if you take in the previous thing, you can see it is 2 was n because there was P1 and P2. Previous example. So that is what, so you can find out n by understanding the number of forward path. So this is very important. So first thing what you're going to do, then pi. Pi is what? Path gain of ith forward path. So you have P1, P2 and all. So you have to write, you have written in the previously you have written G1, G5 and all those things. So that kind of things you have to write when it is path gain. Okay. So these are the two things you understood, n and pi. Now it is delta and delta I. These two things are left out for you. So you just complete it and we'll see what is delta. Delta is determinant of the graph. So how delta is written is very important for us to understand. This is the entire equation for delta. Okay, so here you should understand that how the things has to be written. So if you have completed, just write down delta is the determinant of the graph and try to understand this carefully. Delta is, you can see 1 minus, see here, 1 minus, this is summation of loop gain plus summation of non-touching loops gain taken 2 at a time minus summation of non-touching loops taken 3 at a time. So this is what you have to understand. So let us go back and see what it is exactly. You can see that it is 1 minus, then it is going 1, it is like this. I will just tell you. So you can see it is 1 minus here, then it is plus here, then it is minus and plus, like that it will go. Okay, so you should understand that. So let us see first one. 1 minus, first thing is what? 1 minus loop gain. So what is loop gain? Loop gain is L1, L2 and all you have seen, no? So summation of that. So this is what you will get. So this part you have to see is it is loop gain. So it is L1, L2 and all those things we will get it. So what is next one? Plus summation of non-touching loops gain taken 2 at a time. So here what you are going to take is non-touching loops. Non-touching loops, I have told you what is non-touching loops. What is non-touching loops? Anyone of you can say? What do you mean by non-touching loops?
Common node shouldn't be there, sir.
Yeah, there should not be any common node. So so you have to take non-touching loops gain taken 2 at a time. So here if you have L1 and L3 as non-touching loops, you have to take them together. And third one minus third one is non-touching loops taken 3 at a time. So you should see that there should be 3 non-touching loops, L1, L3 and L7 or something. These all non-touching loops should be three loops should be there which is not touching to each other. Again, if the problem is slightly bigger, means you can see that plus summation of non-touching loops 4 at a time. So what it will be here, it will be L1, L3, L7 and L10 something will be there. So all total 4 loops will be there, that is not touching to each other. So this is what you have to understand. So that is this equation. So it's a general equation for a huge problem as well. So that's why most of the cases problems come still non-touching loops taken 3 at a time maximum for you. I have very rarely seen problems coming that non-touching loops taken 4 at a time. 4 at a time non-touching loops means the problem will be too complicated. Okay, so most of the cases this is what you will get. So delta is summation. Some delta will be called as the determinant of the graph, and you should understand that it is 1 minus summation of loop gain, first you should take, plus summation of non-touching loops gain taken 2 at a time. And if your problem is having still in your problem you are having non-touching loops 3 at a time, then that also you have to take it and move on further. So that is what you have to do. Most of the cases the problems end with non-touching loops taken 3 at a time. Is that clear for you?
Yes, sir.
Is that clear for others also?
Yes, sir.
Okay, so just in a systematic way, we have written 1 minus summation of L1 plus summation of L2 minus summation of L3 plus summation of L4. But this is what you have to understand. This is very important for you to understand this delta. So once the delta is over, we will see what is delta I. So all of you write down the equation for delta. What is delta I is value of delta for a signal flow graph not touching the ith forward path. So this, to understand delta I, it's when we solve the numerical, no, it will be very much clear for you. Delta I is value of delta for the signal flow graph not touching the ith forward path. So since it is in general form, so you may try to understand, it will be sometimes difficult for you. When you go with specific 1 or 2 or 3 loops, no, it becomes easy for you to understand what it is. So delta is taken as value of delta for the signal flow graph not touching the ith forward path. So if you take the ith forward path, there should be not touching the ith forward path. Then it is called as delta I, or delta I can also be written as delta minus summation of loop gain terms in delta that touch the ith forward path. So we will just go with the problem, and then it will be more clear for you how this delta I is all about. Okay, so with an example, when we go with the problem, it will be you will be able to understand in detail what exactly this loop gain terms in delta that touch the ith forward path indicate, so that we can see here. So this is delta and delta I. So you can just write these things, and then we will just go ahead with the problems. So delta I is obtained from delta by removing the loops that touch the ith forward path. So we have to remove those loops, and we have to do that. So here, what you have to understand here is, what do you mean by forward path? What do you mean by forward path gain? What do you mean by loop? What is loop gain? And what do you mean by non-touching loops? And how to take the forward path, how many forward paths are available in a problem, and all these things is what you have to understand. So when we solve the problem, we'll be having the problem here to find the transfer function for the signal flow graph. So when we solve the problem, you will understand that how these things can be brought into consideration. So one problem may be sufficient enough for you to understand. The rest of the problems you will feel convenient to solve it. So you can just note down these things. Is that clear for everyone? This formula is called as the Mason's gain formula, and where you are going to get the transfer function, and the transfer function is given by C of S by R of S, and C of S by R of S is, so what is the transfer function? Summation of I is equal to 1 to n pi delta I divided by delta. So you have completed this. Shall we go with the problem?
Yes, sir.
Okay. So all of you have understood the equation, no? So we will just go ahead with the problem, and we'll try to solve it. So whatever I ask you to do, like I may ask you to go ahead with a forward path. How many forward path is there? So you have to find out the forward path. You need to find out how many loops are there. So you should not make mistakes in finding out these things. If you are able to do those things properly, then for me explaining this problem will be pretty easy to make you understand. And you have to understand what do you mean by loop, what do you mean by loop gain, what is forward path gain, how many loops are there, how many forward paths is there, and what else you have to understand here is how to find out the transfer function. So all these things we'll try solving it. You can just write this problem. Let us see how many steps we can complete by today. We will again start the problem for the next class as well. So this is the first problem. So understand this problem carefully. So first draw this diagram. See, as you know that in the block diagrams, the arrow marks and notations minus plus. Here also this arrow marks and this minus and all is very important. Loops. See, if you do the arrow mark in a different way, your entire problem will go wrong. So you should be careful when you draw it in the answer paper. So the first problem is find the transfer function C of S by R of S for the signal flow graph in figure. So after doing it, you should first step is you should find out the forward path. How many forward paths are there here? So there are certain steps that you have to follow in solving the signal flow graph. So that steps you should strictly follow. You should not uh, eliminate any of the steps. And compared to block diagram, signal flow graph, you will get, you can solve it better. It is easy. Only thing is that you should understand what is forward path, what is path gain, what is loop gain, and all those things. If you understand, it is very easy. So all of you have drawn this figure.
Yes, sir.
Yes, sir.
Okay. How many forward path is there in this figure? Tell first. How many forward path is there? Forward path means once you leave the node, you should not come back to the node again. How many are there? Don't worry, you can say that. Yeah, one. One is correct. Other than this forward path, I don't think you can see any forward path. Can you see
Yes,
any
sir.
other forward path?
No, sir, only one, sir.
Yeah, that's it one. So you can this first step you can write down. There is only one forward path and the path with a path gain. So you need to write it as P1. P1 is equal to G1, G2, G3, G4 and G5. So how many loops are there here? Next question. Okay, fine. You can just see this. We'll go in detail this problem in the next class. Complete hour, we'll take this problem. If you have any doubts with respect to any of the things, you can clarify that. Please go through what all things we have studied with respect to signal flow graph. It's very important so that it becomes easy for us to simplify it further. So all of you go through the things whatever we discussed before, and we will get back in the next class. Okay. 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 Thank you all.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.